Hello everyone, welcome back to Project Pro YouTube channel. This is me Simran Anand, and in this video I'm going to be discussing about a machine learning topic, which is optical character recognition. Optical character recognition can be abbreviated in the form of OCR, and it is becoming really important these days for us to deal with data in different types, because data need not be always structured data. It can be unstructured data, semi-structured data, or even totally a structured data as well. So in order to extract crucial information and to leverage information retrieval techniques, it is becoming really important for us to understand the concept of OCR applied. So in today's video I'm going to be explaining you what is OCR. Firstly, what are the different frameworks, tools which have been developed recently as well in order to implement the optical character recognition technique. I'll also be demonstrating you the Python code in order to implement OCR. We'll also be giving you a gist about what are the different steps and the concepts you must be aware of before delving into the OCR field. So let's get started. This is basically in a Project Pro website. This is the project, which is NLP project to build a resume parser in Python using Spacy. So this does leverage the OCR techniques. But before delving into this project and explaining you, I'd like to give you a gist about this project uses OCR. So firstly, what exactly is OCR? I would like to explain you that. So basically OCR, which the full form of OCR is optical character recognition. It is a machine learning task and a computer vision task as well, which basically identifies or recognizes the text present in an image or document. So basically when you know that convolutional neural networks are able to classify, detect objects present in an image, and so are recurrent neural networks which deal with text. They are able to perform all the NLP techniques, like are able to recognize the named entities present in a text. But how about consider you have an image or a document, say your resume only, and the HR person wants to extract crucial information from a document. So it is not technically feasible for him or her to spend a lot of time in order to skim through your resume and extract crucial information. We need some kind of a technology, which in our case is OCR, in order to extract the important information present in an image or a document. So exactly the concept of extracting or detecting the text present in a document or an image is nothing but optical character recognition. So as the name also says, we are recognizing the different textual characters present in images. Now definitely images can be in JPEG form, PNG form, or in any other form as well. But the main idea, or when you're dealing with multimodal data, that is in memes. So nowadays memes are becoming really common, and we know that text even quotes are embedded in the memes. So when you want to extract the content or the textual characters present in any memes or images, which is multimodal data, we have to understand the process of OCR. So basically, as you can see on my screen, OCR is a 5-step, the main processes involved in OCR. This is just an overview. I'd like to give you firstly, before starting any OCR process, you need to first acquire a set of images. Or if you want, you're just dealing with one single image, you need to acquire an image. So image acquisition is the first step in OCR process, where you are getting or collecting images, which can be any image basically in any format. You can even it not only be images, it can also be documents. So it can be resumes in PDF formats and so on, and it can be collected from any data source. So once you're acquiring the images, the next thing comes pre-processing. The next step is pre-processing, which is a OpenCV task, again a computer vision task, where you have to pre-process the images. Now this is where your CNNs or the convolutional neural networks come into picture. So generally OCR involves both CNN and it's a combination of CNN and RNN, because it's a process where you are also dealing with images and ultimately extracting the text out of an image. So of course you have to use a combination of images and textual neural network. So when you are pre-processing the images, it involves a lot of segmentation techniques into picture. So that's why I've just clubbed them here: pre-processing and segmentation. What is exactly segmentation? Segmentation is basically when you have an image, say image of a person, resume, say, or you just say that PDF of resume, and you're basically categorizing or partitioning the various the different contents present in the image into different categories or different parts. That is called as segmentation, which is nothing but partitioning of the contents present in an image or a PDF or a document. That is called as segmentation. Once the pre-processing and segmentation is done, that is where you get the text area detection, which is nothing but a form of feature extraction. So CNN, as you know, they are able to identify the patterns present in the image after pre-processing and convert into low feature maps. So once you're getting the features are extracted, you get a kind of a region of interest. So as in my previous video, I was explaining you about object detection. This is exactly the same case where the neural network, in your OCR process, a neural network is able to identify what is the region of interest, which is nothing but ROI. Once the ROI has been identified by your network, comes the stage of classification, which is the fourth stage. And classification is where you are classifying the different contents. So it's a textual classification, because once you have identified the regions present in an image, you're giving those partitions and the contents present in those segments of the image, you're assigning them to particular labels or particular categories. So giving a text some categories, nothing but, as you might know, some it can be parts of speech tagging, which is again related to named entity recognition. You have a lot of named entities. How exactly is the model you have trained able to recognize or identify the named entity present in a text, so that a suitable kind of a category or a label can be tagged and assigned to it? That is the purpose where we are using Tesseract, the V5. This is just a sample. Of course, we can make use of the other libraries for OCR as well. I'll be showing you what are the libraries recently developed for implementing OCR. But Tesseract is one important and a very prominent library. Rather, it is an open source Python tool. It was written in C++, but it's now also compatible with Python. So Tesseract OCR is a open source platform or a tool you can make use of for all your OCR projects. So when you're using Tesseract, it is built, the version 5 especially, comes with LSTM, which stands for long short-term memory transformers. So as you know, long short-term memory neural networks, it's a variant of an RNN, or a recurrent neural network. So they deal with they solve the problem of long-term dependencies, and LSTM, they are able to remember information over a long period of time. Thus, it's it gives a good accuracy. So once after that is done, the final stage over here is the post-processing, where you are able to get the result and the category is assigned to the different entities present in your text. So that was a brief overview about what is OCR. Coming to the project which I was talking about, the NLP project to build a resume parser in Python using Specie. What exactly are the NLP the concepts, or the CV as well as the NLP concepts you should be aware of before starting any project in OCR? Let me explain you first that. So now that you have understood what OCR does and how, especially HRs, which are hiring managers, it saves a lot of time for them as well, because they need not, skim through each and every resume. They can just send your resume to a OCR scanner, extract the crucial information which they need. But the main thing is the OCR software and the scanners should be highly accurate. And the accuracy depends on how well it is trained and how exactly you'll be able to do that. So in this project, you have to understand what are the NLP terms and those the CV terms you should be aware of for OCR. So not only this, but even if the document need not be a resume, it can definitely be any kind of document like your PAN card or your Aadhaar card. And when you want you want to extract the crucial information from a particular document, that is something with document parsing, that is where OCR comes into picture. So the data set of resumes in this particular project, a resume, it deals with a lot of information, and the information is also, of course, in unstructured form. It is not in a very structured or a tabulated form. So resumes have, some of them are not even aligned, and the text is like up and down. It's not in proper orientation. So how exactly is our model able to actually give a proper alignment, a tagging to each and every content, so that it's able to properly identify? So when you talk about a resume, there are different categories being assigned. Like, for a text, it can be location, or what a resume contains is designation, your name, your years of experience, the skill sets, the location, and so on. Even it consists of phone numbers, numerical data, and so on, like the email addresses and so on. So we need to build such a kind of a model which is able to extract all these information. So when you talk about the NLP tools, techniques that you have to master, in this we are making use in this project. This uses Specie resume parser. So it uses Specie, which is a Python library, as you may know. So it's a library in Python, which is widely it's being used for NLP projects. You might have heard of NLTK as well, Natural Language Toolkit. So similarly, we have Spacey, and Spacey is an excellent it's a Python library excellently used for NLP projects, especially for document parsing. And when you talk about OCR techniques, so it offers a quick implementation of techniques, all the NLP techniques, which are parts of speech tagging, named entity recognition. It can be done very well with Spacey. So you can see that apart from Spacey, the project, or you have to understand the NLP terms and techniques like tokenization, lemmatization, parts of speech tagging, and stop words elimination. These are common to any NLP project you deal, and I have already explained you what exactly is tokenization, lemmatization, POS tagging, stop words elimination in my previous videos. But to give an overview, it's basically text pre-processing, where you are basically converting a unstructured text, or be it any form of text which is containing a lot of stop words and so on, cleaning the text in a form so that you get the relevant features out of it. So if you say tokenization, it's basically it's tokenizing your text, or breaking a long form of a text into small tokens. Lemmatization is again converting the text into its root form of the word. Parts of speech tagging is where, the different parts of speech, like in English, you have noun, verbs, pronouns, adjectives, and so on. So when you're dealing with a sentence, how exactly are you able to map the different words present in a sentence to the different parts of speech? Like as I said, which one is a noun? Like say if there is a sentence over here like apple over here, it can have two meanings. It can be a company as well, and it can be a proper noun as well as a common noun. So to understand whether it's a tech company or a fruit, which has to be identified by the model, that is called as parts of speech tagging, where a category or suitable category has to be assigned by the model to a particular word, or a part of speech has to be tagged to the word. Stop words elimination is, the different stop words which has to be removed before you actually train your model. That is stop words elimination. Common stop words are the, am, is, and definitely you can add your own set of stop words to customize them in Spacey. So once this is done, you have to understand how is OCR done. In this particular project, we are using Apache Tika, which is an open source library for implementing OCR on the project. When I talk about the common libraries for implementing OCR, there are various developments which have taken place. And apart from Tika, Apache Tika, you can also implement OCR with Tesseract OCR, with Keras OCR, Easy OCR, and the Google Vision API. So these are the different tools and frameworks which you can leverage and make use of to implement OCR technique. In this project, they have used Apache Tika and OCR, which is optical character recognition. Apache Tika over here was used for resume extraction Python project, and they dealt with PDF files. You can definitely have a look at this interesting project to know more as to how Apache Tika was used. But along with, apart from Apache Tika, you can also make use of other open source tools as well, and libraries like Tesseract OCR. This is Tesseract OCR, by the way. This is the site, Tesseract OCR site on GitHub. You can go through the documentation to understand better how exactly is the OCR engine implemented here. And the package, it contains libtesseract, which is and a command line program, which is Tesseract. These what all has to be installed before implementing it in Colab, and so on. So now that you have understood what are the different tools, frameworks which are there for implementing an OCR, you have to again understand what is a machine learning pipeline. At the end, they have built a machine learning pipeline, which is basically it's an end-to-end machine learning project is implemented. So wherein you're using neural networks and all these stages which I've talked about, like the extraction, the parts of speech tagging. Firstly is the data collection and the pre-processing. Next comes the leveraging Spacey in order to perform all the NLP tasks, especially the named entity recognition. After named entity recognition comes the training of the model, OCR using Tika, and so on. How exactly are you connecting all these files which you have built in Python and build a pipeline out of it? So that is where machine learning pipeline comes into picture, and especially when you're using IDs, convenient IDs like Microsoft VS Code. In VS Code, it becomes it comes very handy for you to build a machine learning pipeline where you're connecting all the Python files which are individually doing all these tasks listed above. So this was a resume parser in Python. You can go through the project to understand more about it. Let me quickly explain you. Okay, so this is a Google Collaboratory, wherein I would like to explain you how to use Tesseract. So Tesseract is another open source library for Python for performing OCR. I have just for training purposes and for testing it, I have just passed in few of the images as input. I'll take you through the code to make you understand how OCR is being done here. So firstly, you have to install Tesseract OCR into your Colab environment, Google Colab environment. Once the necessary packages of Tesseract OCR have been installed, next come Tesseract, which is again a wrapper for your Tesseract OCR library for performing OCR, has to be installed. Then a message comes here to restart the runtime, which you have to restart. You just click on restart runtime and the project gets restarted. Next comes, you have to implement all, import all these Python libraries, PyTesseract, then shutil, os, random, and I've just included from pil import image under the try except blocks, that even if there's an so that no import error comes in, and even if there is an exception throws up, so that image library can be imported. So image library is imported from pil, which is below in Python. Once this is done, from google.colab import files, this is where upon when you run this, so let me, I think my I've connected it to the runtime. I'll just again run this cell live. So it shows a live button where it's asking for user input for you to pass in some image. So when you click on choose files over here, you can upload any file. So say I have just taken this sample OCR. Let me just pass in this sample OCR image. Now, once this image has been loaded, it says saving the sample OCR image to JPEG. Since this is the extension JPEG, you will see on your left hand side over here in the files, whatever file you have passed in your, when your runtime is connected, of course, whatever files you have uploaded dynamically as user input, those will get loaded over here and saved. So once it's saved, sample underscore OCR JPEG, you can just pass in the image over here, extracted. So I can just type over here the name of the image. So the name of the image with the extension as well. So it says sample OCR .jpeg. Since it's saved, exactly the extension has to be in the format it gets saved. So it's the lowercase. So let me give sample OCR.jpg. When I'm passing in this function, particular function like PyTesseract.image to string, what it does is basically taking the image, extracting the contents, the textual characters. It's going to identify the textual characters out of this passed in image. And then on printing the extracted information, you will see whatever has been included in the sample OCR image. So if you want to view what image is that which I'm talking about, the sample OCR image. So this is the sample OCR image which I have passed in. Let me just zoom in so that it would be better visible. So this is the sample OCR image where I have passed in a formal document required. So whatever the content is present here, that has been extracted by this, and formal document required by whatever was there in that present in that image has been extracted as textual characters by the OCR model of ours we have trained on, and that has been extracted. Let's again check for another image. Say sample OCR1 is another image I have. So it saves the sample OCR1 image. So once this is done, let us rename this and check how exactly is the information recognized now. You will see this is this as the information. Let us see what is the sample OCR1 image all about. Okay, so this is a sample OCR1 image. As you can see, it's not very structured, and it becomes really difficult for us to even extract information which is present in not a tabulated form, and it's very haphazard in nature. It's also sometimes the alignment may not be proper, and even the font can highly differ. So you must have heard of applicant tracking systems, ATS scanners, especially for resumes. This only depend on OCR technique because they are able to extract information, and various ATS scanners do not perform well because they're not able to identify contents present in a resume, although you have included. So the main purpose, the main reason could be that they have not been trained upon a certain kind of font. They're not able to, basically understand or capture information present in a different style format or present in a different alignment, because it depends on the way it is being trained on. So the more you are training your the OCR model on a larger corpus of data, and by giving it more data set to train on, the better. So if you see, this is it's kind of blur over here, the image, but definitely whatever the content is present has been extracted from the image by this OCR model. Let me now show you an example where you can implement the Keras OCR engine as well. Of course, there are other tools as well, like Easy OCR is one another framework which you can use. So by making use of Keras OCR, you must have you know that Keras, TensorFlow, PyTorch, these are different Python frameworks for performing deep learning, machine learning tasks. So this is where I've just used Keras OCR library. I didn't use Tesseract OCR. I've made use of the Keras OCR, installed it. All the necessary content, the necessary packages have been imported and loaded into the collab environment. Then this is the pipeline method or the package I have imported here. It's kr.pipeline. So once this is done, extracting the images. So I have passed in a set of images here, 5 images, which are actually memes. I was talking about meme, when you are actually want to extract information present in memes and present in different different multimedia formats. Like it can be even multi-model images and so on. It can be even quotes which are present in different snippets of images present in Reddit, Pinterest, and so on. So how exactly are you able to extract the content? I've passed in a set of sample 5 images, and the length of the number of images passed in this list is 5. So plotting the first image, I've made use of the PLT, which is the matplotlib library here. So plt.imshow, this is the OpenCV function imshow, which is to just plot your image. So this shows your image, what exactly you have passed in. This is the first image I have passed. Similarly, the second image I have passed. The figure size is 5 cross 5, which is length and width is 5, set to 5. And this is the third image passed, fourth image, and the fifth image. So whichever is now in this image, I'm not extracting. The end goal is not to just extract the image, the text present in the image, but also to localize or give me the bounding box or the labeling in this image itself. So basically segmentation. So show me the segmentation where how this particular library, Keras OCR, and the pipeline.recognize method will actually give me a labeling around the text present in the image. So if you see here, when you and your friend, this has to be labeled. So along with that, let us check that whether we are actually able to get the labeling or not. So in the predictions part, where I am implementing the character detector here, I have just iterated over the images present in the zip of functions and the zip of images, and then drawing annotations. So KR is Keras. So kr.tools.draw annotations, as you wrote, annotations are nothing but labelings or bounding boxes drawn around the textual characters present in the image. So this draw annotations function over here and passing in the image, the predictions, and the axis. Once this is done, you will see the labeling around the text. So you will see minutes to each and every entity has been identified accurately by this OCR model, and you will see whatever is the text present here, like life is beautiful, it has been identified. Life is treated as a separate entity, and so is and so is beautiful. So if you see, they're not, they're just not text, but each word of the text is treated as a separate part, like happy and birthday are separate entities. So this is an example of how you can also make use of the Keras OCR library. And there's another library like Easy OCR, which makes use of OCR, which is used for performing OCR and can also be annotating your images accordingly. That was all about it, and I hope I have given you an understanding of what is the different stages present in OCR and how important it's becoming these days to not only parse documents but also images and to deal with multi-model data, which can be unstructured as well in documents and so on. So do check out the Project Pro website to know more about various interesting projects, because Project Pro is the best platform for you, whoever is interested in data science and knowing about new projects, because Project Pro is a curated library of solved and verified end-to-end project solutions, and all the project solutions are developed by the industry experts working in the top global tech companies. Also do buy the subscription plan to avail access to 250 plus solved end-to-end projects. Stay tuned on the Project Pro YouTube channel. Like, share. Thank you so much.
Project Pro, the only solution for solved industrial grade projects.